Hello students, in this video we're going to do differentiation of trigonometric functions. Do get a pen and some papers and practice along with me. So are you ready? Right, let's look at some important concepts that are needed before we go on to problem solving. What are the basic concepts needed? The derivative of sine x will give you cos x. Derivative of cos x will give you negative sine x. The derivative of tangent x will give you secant square x. So all other concepts will be based on these three basic differentiation of these trigonometric functions. Let's look at if you're asked to find the derivative of sine bracket ax plus b, right, basically this involves two steps. The first step is just to focus on differentiating sine bracket ax plus b. So if you look at the basic concepts here they're given, you differentiate sine x, you get cos x, right? So you differentiate sine bracket ax plus b, you should get cos bracket ax plus b. However, it does not end there. You still have to differentiate whatever that's inside the bracket. So this is what I mean by a two-step process. This is a two-step process. Right, so at the end, you will end up getting, by rearranging it, because when you differentiate ax plus b, you get a. So putting the a in front of your cos, you end up getting a cos bracket ax plus b. So how about differentiation of cos bracket ax plus b? If you used the same method as what I've explained just now, you differentiate cos bracket ax plus b, you get negative sine ax plus b, then times a. So that ends up getting negative a sine bracket ax plus b. So do the same for your tangent, and you will get a secant square ax plus b. Right. Sometimes you'll be given a more difficult task, and that when you have to deal with power. So supposing if you're given asked to find the derivative of sine to the power of n bracket ax plus b. So in this case here, it involves three steps. So what are the three steps? The first step involves the power. Right, where you need to bring the power down is similar to the power rule that we learned in the simple differentiation. Bring the power down, and then the power minus 1. So this is step 1. Okay, that is step 1. Then followed by step 2, where you just focus on differentiating sine, not looking at the power at all, not looking at the power, just look at sine bracket ax plus b. So that is step 2. Followed by step 3, where you need to differentiate whatever that's inside the bracket. That is step 3. So this is a 3 steps process. So it's harder than, so we start with the basic, which is just 1 step, go on to intermediate, which is 2 steps, and come to the advanced, which is 3 steps. Right. So where does all these 3 steps lead us to? All right. So step 2 will give us cosine ax plus b. Step 3 will give us a. So you can rearrange it, all right, to give you a n sine bracket a n sine to the power n minus 1 bracket ax plus b, then cos bracket ax plus b. Okay, right, you can do the same for cosine to the power of n ax plus b, right, and you end up, so there's a negative there. Why negative? Because when you differentiate cos, you're supposed to get negative sine x. That's explain why I have a negative there. So rearranging it, you get negative a n cosine to the power n minus 1 bracket ax plus b sine bracket ax plus b. Right. So you do the same for your tangent, and right, and this is what you end up with. Rearrange it. Alright, so these are basically the concepts that are needed. Right, let's look at the first questions. So for the first questions, we're asked to differentiate tangent bracket 2x plus 1 to respect to x. So if you were to recall what we've learned earlier on, differentiating tangent bracket 2x plus 1 will involve two steps. What are they? The first step is you just differentiate tangent. That will give you secant squared bracket 2x plus 1. Second step is differentiating whatever that's inside the bracket, which is your 2x plus 1. And you end up getting 2 secant squared 2x plus 1. Alright, let's look at part 2. So we asked to explain why this particular curve has no stationary point. So to explain that it has no stationary point, if there is a stationary point, then dy dx will be equal to 0. So some of you may do it that way. You may assume that supposing there's a stationary point and you let dy dx equal to 0 and you realize that there's no values of x that satisfy dy dx equal to 0. I think a better way of doing it were to prove that it is an increasing or decreasing function, because increasing or decreasing function has no stationary point. So I think it's increasing. Increasing means when the x increases, y increases. Decreasing is when the x get bigger, your y get smaller. That's decreasing, right? So I think it's better to explain it in that manner, right? So from what I have got in part I for your differentiations of tangent bracket 2x plus 1, we're going to write it as secant squared is actually 1 over cos squared. So this can be written as 2 over 1 times 1 over cos squared bracket 2x plus 1. That explains how I get this term here, right? You just multiply numerator, multiply the denominator. All right, so we need to explain how we end up getting a increasing function. So we just zero into the denominator. All right, so for all real values of x, when you have like x squared, you definitely will, when you square it, you will have x squared more than equal to 0, right? So likewise for this also, you have cos squared bracket 2x plus 1. But because this is a fraction, you can't have denominator equal to 0. You can't have something over 0 that's undefined, right? So basically, we just need to say that cos squared bracket 2x plus 1 has to be positive. All right, this one cannot be equal to 0. So therefore, your 2 over cos squared bracket 2x plus 1, it's more than 0. If that is more than 0, what we are saying is, like when we say dy dx more than 0, it means y is an increasing function, right? So since we're saying that this one is derived from this one, so we are saying that that is also more than 0. And that is more than 0, what does it mean? It means y is an increasing function. And for an increasing functions or decreasing function, it has no stationary point. So I think it is better to explain it this way, rather than let dy dx equal to 0 and then conclude there's no values of x. Alright, let's look at question 2. So for question 2, you're given equations of the curve, which is y equals to sine x over 2 minus cos x. And you ask to find the x coordinate. Your x coordinate is actually in the first quadrant because it's between 0 and pi over 2 at the x coordinate of the point at which the tangent to the curve is parallel to the x-axis. So if you don't quite understand how is it, it's always good to come up with a diagram. Of course, you don't really need to know exactly how the curve looks like. You just need to know that it's a curve. So just draw a curve. And then we just need to know there's a particular point there. Okay. We need to find that particular point. You can call it P, Q, A, whatever you want. I'm just going to call it X because I need to find the X coordinate, right? So this particular point, we can have a tangent line, the tangent line. And this tangent line is parallel to my x-axis. So what are the concepts involved here? So x-axis is a horizontal line, right? Right, so horizontal line will have dy dx gradient equals to 0. Horizontal line will have gradient equals to 0, right? Okay, and if this particular tangent line is parallel to your x-axis, means it have the same gradient, which means this particular tangent line also have your gradient equals to 0, which is your dy dx equal to 0. Okay, so we have to first of all go on to find dy dx. So we need to differentiate your curve. So you can just let the numerator be u, denominator be v. Differentiate sine x, you get cos x. Differentiate 2 minus cos x. Differentiate 2, you get 0. Differentiate cos x, you get negative sine x. So you end up getting just sine x. All right, and then this is the concept that I have explained earlier on. Right, so apply the quotient rule. Okay, and then at this step here, all right, if you see there's a negative in front of a cos square x, you can just factorize it to get 2 cos x minus bracket. Why do I want to factorize it? I'll explain to you why. Because by factorizing the negative out, you will get cos square x plus sine square x, which is equals to 1. Able to remember your trigo identities. The three trigo identities, right? One of them is sine square x plus cos square x equals to 1. So that's the reason why I want to factorize the negative out, so that I can just make my expression look simpler to get 2 cos x minus 1 over bracket 2 minus cos x, close bracket to the power of 2. Okay, I'm going to let that equals to 0. I need to clear this space. Okay, letting that equals to 0, this is what I'll end up with. Right, basically you can just do a cross multiply. So you will end up getting 2 cos x minus 1 equals to 1. Right, and if you remember how we solve trigo equations, you need to find the reference angle, which is cosine inverse half, and that gives you pi over 3. Now the range given, okay, for differentiation and integrations of trigo functions, okay, the unit is always in radian mode. Right, so cosine inverse half is actually a special angle. It's 60 degrees, pi over 3. And you just need it to be in the first quadrant. So therefore, your x is just pi over 3. And that's it. Right, let's look at the next question. So next questions are given a curve and a normal. There's a normal to the curve. And you want to find the equations of the normal because you want to find the, the normal to the curve at the point where the curve crosses. Okay, it seems like so complicated. Why talking? Okay, no worry. You can just use a diagram to sketch it out. So like what I've done just now, we don't need to exactly know how 1 minus 3 tangent x looks like. Basically, just draw a curve, and then we know there's a particular point there. Okay, and at that particular point, we can have a tangent line. And then a good friend of a tangent line is a normal line. Okay, this is bad drawing because my normal line is supposed to pass through the cross. Okay, never mind. Alright, so this is tangent. So tangent is always good friend with normal. Okay, they're good friend. Alright, so the normal to this curve at the point where the curve crosses the y-axis passes through this point. Alright, so there are two things there. What they're trying to say is that there's a particular this normal actually will pass through this point here called k, 3. Right. And why am I told that this curve passes through the y-axis? What is the rationale by telling me this? Because when you want to find equations of any line, right, you're going to use this formula, right? Y minus y1 equals to m bracket x minus x1, right? So I need to know what is my x1, y1. I need to know what is m, right? So that I can substitute into this equation here to find my equations of the normal. So by telling you that the curve crosses the y-axis is to tell you what point to use for your x1, y1. Okay, so this is what we need to do. First, we need to, I'm not too sure what I did. I think I find dy dx first. Okay, so that's find dy dx first. Right, so you differentiate 1, you get 0. Differentiate tangent x, you get secant square x. So it end up getting negative 3 secant square x. Right, so we need to know what to substitute for x, right? Which is precisely what I said earlier on. The curve crosses the y-axis. That is when your x is equals to 0. Okay, so sub x equals to 0 because the curve crosses x, the y-axis. So on your y-axis is when the x is equals to 0. So we find the gradient. You have to change secant square x to 1 over cos square x. So that gives you negative 3 over cos square x. Substitute x will be 0. So cos squared 0 is 1, so you get negative 3. So that is your gradient of your tangent line. This one. This is gradient equals to negative 3. But I want to find the gradient of a normal. So gradient of normal will be negative 1 divided by negative 3, which is 1/3. Okay, but I'm still not done yet. Not done yet because I need to find the point, right? I need to find my x1, y1, right? I know my x is 0, so I need to substitute x to be 0 into your equations of the curve to get my y. And that ends up y equals to 1. So now I have the point x1, y1 at the gradient. I can substitute into this to find my equations of the normal line. Okay, I need to erase all this because it's messy. So equations of the normal line will be y minus y1. So the point, that means my x1 comma y1 is 0 comma 1. So y minus 1 equals to gradient 1/3 x minus 0. You get y equals to 1/3 x plus 1. Alright, so we mentioned earlier on that this particular point lies on your normal line. So we're going to substitute your x to be k, your y to be 3. You will get 1/3 k plus 1. So you get k equals to 6. Because 3 minus 1 is 2. 2 times 3 gives you 6. Alright. So for questions like that, you know, if you cannot visualize it, just use diagram. Right, let's look at the next questions. For the next questions, you're given y equals to sine 2x minus 3 cos x. Find the gradient of the curve when x equals to pi over 6. And for part 2, it's related to what we have learned earlier on, rate of change. So that's the reason why math is actually a progressive subject. Okay, if you do not learn rate of change, and then you'll find that when it comes to this differentiation of trigo functions, you will be at roadblock. It's like you can't go on. You know what I mean? So that's the reason why you cannot have too many concepts that you're not sure of. Whatever concepts you're not sure of, you have to clear it. Otherwise, it's like having too many things in the room and you find it very difficult to declutter. Okay, right, so part I, just find dy dx. That's quite easy. You differentiate. It's a two-step. Sine 2x is a two-step one. Differentiate sine 2x, you get cos 2x, then times differentiation of 2x. So if you're one of those always forget to differentiate the bracket, just put the bracket like that. Then they'll remind you that you must always go on to differentiate whatever is inside the bracket. Differentiate 2x, you get 2. So you end up getting 2 cos 2x. And then differentiate 3 cos x. You differentiate cos x as negative sine x. Okay, so you simplify it, you will get 2 cos 2x plus 3 sine x. Okay, so we need to substitute x equals to pi over 6. Alright, so pi over 6 is basically a special angle. Right, so you will end up getting 2 cos pi over 3, which is 2 cos 60, which is cos 60 is half special angle, or you can just use your calculator. But if you use the calculator, be careful. You have to use pi as in pi lah, the pi in the calculator. Right, so you end up getting dy dx is 2.5. So you have to watch out. Okay, why do I say have to watch out? Because we are lucky in these questions that you are just getting cosine 60, which is half, sine 30, which is half. If you're getting cos 30 and sine 60, then Depending on the questions, if the question say exact value, then you can't use a calculator anymore. Because cos 30 will give you square root 3 over 2. Some questions, they want you to leave your answer in exact value. So you have to be careful when you're dealing with special angle. All right, let's look at part 2. Part 2 is rate of change. So if you were to recall how we do rate of change, yes, x is increasing at a constant rate of 0.06 units per second. So converting this to mathematical symbol, it means dx over dt is equal to 0.06. Then what are we asked to find? We're asked to find dy over dt. So this is a connected rate of change. You've forgotten how to do that, please go back and revise. Go back as in go back to the previous video and revise. So we found dy dx will be 2.5 times 0.06. So the rate of change for your y will be 3 over 20 units per second. Okay, so answer to the question asked. Always answer to the question asked. So therefore, rate of change of y is 3 over 20 units per second. Right, let's look at the second last question. So the second last question, there are 4 parts to the questions. The first 2 parts are actually just from the chapter on the trigo using R formula. Right, so that's the reason why you can't actually learn A math by trying to compartmentalize it. Meaning you just can't say that, hey, I want to learn only chapter 3, 5, 6, 7, 8 or something like that, and the rest I don't want to learn. You can't do that, okay, because it's a progressive subject. All the concepts are more or less interrelated. Right, so for part I, you was asked to show that the perimeter of the trapezium, the metal plate is in the shape of a trapezium. So you asked to find the perimeter to be given by P equals to 22 plus 12 cos theta plus 12 sin theta. So what, if you were to recall, our experience of learning, experience of problem solving in the chapter on trigonometry, right, to find perimeter of this trapezium means I will need to know all the sides, right? So I'm given 5 cm, I'm given 12 cm, but I do not know how long this is. So I need to find that. And I also need to find this, right? And if you were to remember, usually to find perimeter or area in this chapter, our experience is to use Torcaso. Actually, you can also get a little bit hint from here, like cos theta, sin theta. So Torcaso means you have to have a right angle triangle. Then you can use Torcaso, right? So which means we need to like force out a right angle triangle. So how do we force it out? So we force out in this manner. Why do we force out this manner? Because this one, to find Kn, I already know this is 5. So I just need to find this value. Right, so that plus 5 will give me Kn. So that gives me an idea that the right angle triangle has to be somewhere there, right? Okay, so I can use Torcaso, cosine theta. Label the point as A. So An will be 12 cos theta. Am will be 12 sin theta. And then basically now you can add up all of them to get 22 plus 12 cos theta plus 12 sin theta. So that's part I. So for part 3 is linked to your R formula. Linked to your R formula, right? So again, if you've forgotten R formula, please revise. So we're going to use the formula directly. So just going to write down the values of A and B. So this is your values of A, which is 12. This one is a value of B, which is 12. So R is just square root of A squared plus B squared. And that gives you square root 288. So you can write 288 as 2 times 144. You can apply the rules that we learned in SERTs. So square root 144 will be 12. So 12 square root 2. Okay, and alpha will be just tangent inverse B over A, tangent inverse 1. 12 divided by 12 is 1, which is pi over 4. Okay, so we plug everything inside. So for part 2, just to ask to state the maximum parameter. So if you maximum parameter is when this value is maximum value is 1, right? So that will be 22 plus 12 square root 2 times 1, which give you 39.0 cm squared. So part I part I and part 2, the 5 marks, is actually from the chapter on trigonometry. Right, so part 3 and part 4 are related, okay, to differentiation of trigo functions. So for part 3 is still, okay, part 3 is still under trigonometry because you asked to show that the area is given by a equals to 60 sine theta plus 36 sine 2 theta. So that is still trigo. Alright, so we have to find area of a trapezium. So area of a trapezium, if you remember the formula, yes, it's half times sum of the parallel sides times perpendicular height. So where are your parallel sides? So these two are your parallel sides. Okay, your kn, which is 5 plus 12 cos theta, and then your lm, which is 5. Then your perpendicular height will be kl, which we found earlier on to be 12 sine theta. Alright, so we're going to show that that value is equals to this. Alright, so how do we show it? Let's open up the bracket. Okay, and if you were to remember your double angle formula, your sine 2 theta is 2 right. So I'm going to break up 72 to be 36 times 2 because I need to write it like that. Then I can use sine 2 theta. So 72 is 36 times 2. Right. And this I can apply my double angle. Right. Will give us what I need to show there. Okay. Why is it that they want us to write it in this form? Why can't we just leave it as the 60 sine theta plus 72 sine theta cos theta? Why do you want to go to the extra mile? Yes, because in part 4 we need to find the a over the theta. And if you express it as 36 sine 2 theta, is easier for us to do differentiation, for us to differentiate. If you leave it at 72 sine theta cos theta, I have to use product rule, which involve more steps. Okay, so we need to appreciate why the question wants us to go to the extra mile. So to make our life easier for part 4. Alright, so we're given that the maximum area, okay, the plate will give us a stationary value, and this stationary value is a maximum. So when you are told that y has a maximum or minimum value, means dy dx equal to 0. So if I'm told that this plate has a maximum or minimum area, we're saying the a over the theta is equal to 0. So basically I need to find my dA over the theta. That means I need to differentiate 60 sine theta, that will give me 60 cos theta. I need to differentiate 36 sine 2 theta, that will give me 36 cos 2 theta times, remember to differentiate the 2 theta, that give me 2. Right, so you end up getting 60 cos theta plus 72 cos 2 theta equals to 0. You can divide by 6 first and then divide by 2. Oh, so basically you can divide by 12. Divide by 12 to get 5 cos theta plus 6 cos 2 theta. So that is solving trigo equation, you see. So if you're not strong in your trigo, you will realize that you get stuck here. Okay, so how do we solve it? So to solve it, cos 2 theta, remember your double angle? Yes, we can replace it by 2 cos squared theta minus 1. Why do I want to do that? So that I can generate a quadratic equations where I can factorize it. In this case here, I have to factorize using quadratic formula, because the value for cos theta is not a whole number. So you can't use your try and error method. You have to use quadratic formula. So that is the difficult part. Alright, so if you look at the diagram, cosine theta, angle theta is between 0 and 90, so we can just ignore the negative answer. Okay, because the cosine theta has to be positive. So you just ignore this negative. So cos theta is 0.52885 reference angle again, which is 1.01. Remember this, in this differentiation integrations, your unit for triple function must be in radian mode. So make sure you turn the calculator mode in your calculator to radian. So 1.01, but that's not the end yet. Why? Because we need to show that it is a maximum area. Don't need lah, because they never require us to show it's the maximum. It just ask you to find the values of theta. Right, let's look at the last questions. Last questions, you are given the curve has the equation y equals to 2 sine x over 5 minus cos x, and the x is between 0 and 2 pi inclusive. Find the expressions for dy over dx. And part 2, find the range of values of x for which the curve is decreasing. Okay, so let's do part I. That's relatively easy. We just apply quotient rule to do that. So you let the numerator be u, denominator be v. The u over the x will be just 2 cos x. The v over the x, you differentiate 5, you get 0. You differentiate cos x, you get negative sine x. So negative times negative become positive sine x. Write down the formula for applying the quotient rule. Write it down, keep writing it down so that you can remember it so that it will be in a long-term memory, so you don't really need to make an effort to memorize it, you understand? So every time you need to use it, you just keep writing, and then you just stay there. Alright, so substitute in the values for v, the u over the x, u, the v over the x, and v squared. Okay, simplify further. Alright, you can see that I can actually, there's a common factor negative 2 here, where I can just extract it. Okay, I skip one step here. If you extract your negative 2, you end up getting cos squared x plus sine squared x. And cos squared x plus sine squared x is equals to 1. So 1 times negative 2 gives you negative 2. That explains why negative 2 there. So basically that's your expression for dy dx. Okay, and you factorize, because tan cos x minus 2, there's a common factor 2, so you factorize the 2 out. Why would you factorize the 2 out? It's easier to do part 2. Okay, we'll look at, right, so we have found in part I the value for dy over dx. So for part 2, you're told that curve is decreasing and asked to find the range of values of x. For decreasing curve is when the dy over dx is less than 0. Alright, so we're just going to, how do you go about solving this quadratic inequality? You cannot do anything, you cannot do such thing as cross multiply, because this is an inequality. Inequality, there's no such thing as cross multiply, okay, please. So for inequality, what do we do? Just look at the denominator. You see that for all real values of x, the denominator is a positive value. So therefore, your numerator must be negative, because negative over positive then will give you resultant negative, because the resultant answer must be a negative value. So if your denominator is positive, your numerator has to be negative, right? So divide by 2 throughout. 2 is a positive value, so it will not affect your inequality sign at all. Alright, so for solving inequality, you must watch out. It's not the same as solving an equation. So that goes back to your chapter 2 or chapter 3 in the set 3 syllabus, solving inequality. We have to draw the quadratic curve, right? But to do that, let's find your x-intercept first, right? So to find x-intercept is like solving the equation for 5 cos x minus 1 equals to 0. So how do we do it? Yes, you have to find a reference angle, right? Reference angle will be cosine inverse 1/5. Cosine inverse 1/5 is a positive value, right? So which are the possible quadrants for cosine to be positive? Yes, first and the fourth quadrant, right? First and fourth quadrant. So that will be your 2 x-intercept. So you can sketch your curve for your 2 x-intercept. And we want this part of your curve. Your curve will have more than 0 or less than 0. But if you go back to your questions, you want it to be less than 0, which is this part of your curve here. And for this part of the curve, which is less than 0, that means below the x-axis, your range of values of x will be between 1.37 and 4.91. Okay, so this is how we solve it.